All right. Well, we're going to continue talking about how to define nth terms, okay, nth terms of sequences. Now, there are many different ways of finding nth terms. Now, basically, the keys to finding nth terms is you look for patterns, okay, look for patterns. And then you want to put this pattern in terms of n. So you want to create an equation. That's what we're going to do here, create an equation, all right, in terms of n, all right, in terms of n. So that's what it means to find explicit definition or nth term. So there are some basic ones that we always want to look for. One of the basic patterns that we always want to see and identify is what's known as an arithmetic sequence. All right, an arithmetic sequence. Now, an arithmetic sequence is a number pattern that is linear. So when we talk about number patterns, if we see that we have a linear number pattern, then it's going to be what's called arithmetic. Now, what are linear number patterns? Well, a linear, if you talk about functions, and remember, if you watched my other tutorial, I always like to think of sequences like functions. I'm very familiar with functions, and I also good at identifying number patterns as well. But when we're doing this, when we're looking for number patterns that are linear, lines have specific things. They have a slope. That's probably the main thing. They have a slope. And to find a slope, we need 2 points. So we have y2 minus y1. So the difference in the y's, so change in y over change in x. All right. And so we have x2 minus x1. Well, to translate that into when we talk about definitions or explicit definitions, what we're going to look for is there a change? Is there a common difference? So when we look for slopes, we're going to see, is there a common difference? Okay, is there a common difference? A common difference. Now, what does this mean? Well, I have an example of what is an arithmetic sequence. Okay, what is it? All right, what is an arithmetic sequence? Now, if you notice this right here, you can see it's 21.5, 18.5, 15.5, 12.5, 9.5, dot, dot, dot. I want to look for the nth term. Well, if you're good and you notice this, you probably noticed that, hey, what's happening? It appears that I'm subtracting 3 each time. So each one of these, it appears to be subtracting 3. All right? So if I would write this out, my first term, which is 21.5, I can find my second term by taking the first term and subtracting 3. I can find my third term by taking my second term and subtracting 3. Correct? I can take my fourth term, all right, and find my fourth term. I take my third term and subtract 3. So if I wanted to write this out, given my first term, I can write out a recursive definition. Here's my first term, 21.5. And so a sub n, all right, this is recursive, is that we are taking our previous term, a sub n minus 1, that's the previous term, and we're subtracting 3. Subtracting 3. Okay, well, that's all fine, well, and good, and that's a recursive definition. All right, we can find it that way. But I want to find an nth term, okay? An nth term that's not recursive. It's not recursive. Well, since we're subtracting 3, if you graph this out, you notice that it is going down at the same rate. Well, if you have the same rate, a rate is a slope, and a slope is actually a common difference. It's a common difference. And so what we have is actually, when we have this, is we actually have an equation of a line. And this line, I would kind of do this, maybe starting at 1, because this is my a sub 1. All right, a sub 2, a sub 3, and then maybe I'll just graph this out real quick. All right, and we go to 21.5, and we have 21.5. I'll just put 21.5 right there. All right, then when 2 is going to be 3 down, more down, so it's going to go right there and go 3 units down. Oh man, this is going to be really bad. But 3 units down, and we'd have this, and then we go another one over here, 3 units down, we have that. Okay, if we keep on doing this, and obviously this is not really well, but we notice we have this pattern. Okay, it's a decreasing pattern, but it turns into a line. Well, lines, all right, have this basic equation of y equals mx plus b. Or if you want to use point slope form, you take your slope, and you take your x minus your x sub 1. Oops. Give it a point. And then you have your other point, and you put it in there. Your y value. That's point slope form. Well, remember, sequences are like functions, except they have a domain, which is all real integers, or positive integers, that is. So if I wanted to make a nth term for this one, let's see if I can plug in the things into this equation. Instead of having y is actually equivalent to a sub n. So a sub n equals y. So it's like my function form. My slope is my common difference. So this right here, because I'm subtracting 3 each time, that's my common difference, which actually equals my slope. So I'm going to put my slope in here. All right. The next thing is I'm going to take my point. All right. Oops. No, I'm not using x because we're using n. So I'm going to put n instead of x. And now I'm going to take a point. Now, what point can I use? Well, any of the points up here, I just use a term. So let's just use the first term because that's usually the easiest. And I'll take my term and I'll plug it in there. So I'm going to have one of these values, which is going to be, all right, 1 is my x, that's my input. That's my x. I have 1. And then my y value is going to be my output, which is my term value. So I have 21.5. Now, I could use any of these terms, all right, but I just picked the first one because it's easiest because it has 1, all right, for its input. All right, well, let's simplify this and put it into slope-intercept form. And what we have right here is a sub n equals -3. Distribute that through. -3. We have plus 4. And then we have plus 21.5. We'll add those together. So a sub n equals -3n plus 25.5. And that is my nth term. If I plug in 1, I get 21.5. If I plugged in 2, I get 18.5. If I plug in 3, I get 15.5, and so on and so forth. So that's what we have. Noticing that there's a common difference where you're adding or subtracting a common number each time, we realize this is like a slope or a linear pattern. We then can create a line for it. This line, all right, if we translate it, and I'll do this right here, is that if we translate this right here, we can just plug any point in there. So when we have this, or if I want to put it using that form, all right, we can have y, which is a sub n, equals the difference, x, and, oops, not x, n, apologize, right here. And then it's going to be plus, well, what's our y-intercept? Well, that would be a sub 0, a sub 0. All right, what a sub 0 is what's the value when you have an integer of 0 in there. And there you go. And that's our value. Okay. We can also translate it that way by using slope-intercept form, but you just have to make sure that you know what everything entails. Okay. This is just a point or a term. This is my slope or common difference, and y is a sub n. And there you go. And so there's what we have for arithmetic sequences. Okay. So this is what an arithmetic sequence is, and we're going to go through some examples in the next tutorial.